Okay, we're now going to have a look at a few examples of how to solve first order differential equations. So here we want to find the general solution of dy by dx plus y is equal to 6e to the power 2x. And remember, the general form of this, we know to use this when our function is in this form here, is equal to q to the power, or q of x. Okay, sorry, that should be p of x multiplying y. Okay, so we can see clearly that this expression is in this format here. Okay, so the first thing we need to do is we need to identify what is p of x and what is q of x. I actually usually like to write that down at the side. P of x is a number, or the coefficient of y, the thing that multiplies y. So here p of x is 1. And q of x is going to be 6 e to the 2x. In order to solve this differential equation, we're going to need to identify our integrating factor. Integrating factor. That is sometimes denoted as I of x or mu of x. I'm going to use mu of x. Okay, so the integrating factor we find as we do is the exponential raised to the power of the integral of p of x. So what we need to do is we need to find the integral of p of x with respect to x. So I'm going to do that at the side. Okay, so the integral of p of x with respect to x, well, that's going to be the integral. Well, what is p of x? Well, p of x is just 1. So that's going to be the integral of 1 dx, which is just going to be x. I'm not going to put in plus c here, we'll put plus c, our constant of integration, much later on in our problem. Okay, so we now know what the integral of p of x is, it's x, so our integrating factor is going to be e to the power x. Okay, so that's like step 1. Once we've found our integrating factor, we multiply throughout by the integrating factor. And what happens generally, I'll just say generally what happens. And this will always be the case when we multiply through by the integrating factor. It will become the form of the integrating factor multiplied by y is equal to the integral of the integrating factor multiplied by our function q of x. Okay, it will always go to that form. Okay, so if we are multiplying throughout here by mu of x, it's going to go into this general form here. Okay, so my integrating factor is e to the power x, so that's going to become e to the power xy is equal to the integral of e to the power x times qx. And remember up here we said that qx was 6e to the 2x with respect to x. So e to the xy, I'm just going to simplify this into grand, so that's going to be 6e to the 3x with respect to x. Okay, I'm now going to integrate. So this is just one of our standard integrals given to you in your formula, so that's going to become 6e to the 3x over 3 plus c. This is the stage where we put our plus c. We can simplify. That's going to become 2e to the 3x plus c. And eventually we want to make y the subject to get the general solution. So I'll divide throughout by e to the x. I'll write it out like this to start off with. You could probably skip this line. Plus c over e to the x. And here we've got a power divided by a power, so we can subtract. So we've got 3x take away x, which is going to be 2x. That's going to be 2e to the 2x plus c over e to the power x. General kind of strategy for this question is you need to ensure we've got dy by dx on its own. For example, if we had 3 dy by dx, we would need to divide everything by 3. Or if we had 1 plus x squared dy by dx, we would need to divide everything by dy by dx. Okay? Once we do that, we identify p of x and q of x. We then find our integrating factor, which is mu of x, which we find is the exponent of the integral of p of x. Once we've found the integrating factor, we multiply throughout, by that integrating factor, and it will always go to the form, oops, not that form, there we go, mu to the x, y is equal to the integral of this here. From there, we would integrate the right hand side, then rearrange for y. Generally, that's like your kind of bullet points through each of these problems. I'll have a look at quite a few, but generally once you get going with them, apart from some integration problems, it should be not too bad. Okay, thanks very much.